Hello everyone, welcome to lesson 324, day 2. We're going to talk a little bit more about adding and subtracting rational expressions. So just a recap from yesterday, what we had learned about adding and subtracting rational expressions. We learned that we have to have the same denominator before we can do any of the adding and subtracting. So when we do these, the first thing we want to check the bottoms of our two fractions, right? So we have one fraction here, we have another fraction here, and we want to make sure that these things are the same. If they're not, then we have to do a little bit of rewriting before we can do the actual subtraction or addition or whatever it is they are requesting. All right. Once we do have common denominators, we can go ahead and do the addition or subtraction. So when we do that, we keep the bottom numbers in our final answer and then add and subtract the tops. All right, so let me demonstrate here on this first problem. All right, so first thing I'm looking at are the bottoms. I notice they are not the same. This one has a 3 and an x minus 4, right? So it's got two factors down there. And when I look at this one has a 3, right? So they're not quite the same. This one has something that this one doesn't, right? So this one has an x minus 4 where this one doesn't. It has the 3, right? They both have a 3 in the bottom, but this one has an x minus 4 and this one doesn't. So to fix that, I'm going to multiply the bottom by x minus 4. Right? And then what I showed you yesterday, the trick that I showed you was to also multiply the top by x minus 4. It's very similar to what we do when there's just numbers involved, right? We're multiplying the top and the bottom by the same number because this is just 1. It doesn't change the value of our original expression. Okay, so I'm going to go ahead and multiply that. So I'm going to write this out, right? We didn't do anything to the first fraction, so I'm just going to write that down the way I see it. So I've got 6x over 3 times x minus 4 minus, and then over here we're going to do 2 times x minus 4 over 3 times x minus 4. I know it doesn't look a whole lot different, but all we did there, we multiplied, so I put everything together. And now when I look at my two fractions and I look at the bottoms, right, if I look at the denominators down here, they are now exactly the same. So now I can perform my operation. I can actually subtract. And when we subtract fractions, we keep the bottoms of the two fractions. So my new fraction, or the result here, is going to have a denominator of 3 times x minus 4. And then we just subtract the top, right? So we're going to have 6x minus 2 times x minus 4. So all of that goes in the top. Now at this point we can do a little bit of simplifying here. So I'm going to work down, right, and just do some simplifying in the top. Don't worry about the bottom. All right. So here in the top I see a parenthesis, so I can distribute this negative 2 to each term inside of the parentheses, right? So we get 6x minus 2x, right? Because negative 2 times x is negative 2x, and then negative 2 times 4 is positive 8. And this is all still over 3 times x minus 4, right? So I can do a little bit more here. I can combine like terms in the top, right? So I can do 6x minus 2x. Well, that is just 4x. So I've got 4x plus 8 over 3 times x minus 4. Okay. All right. Now, this is going to seem a little bit tricky, but last step here, there's one more thing I can do, and I can actually factor something out of the top. Now watch this. I can rewrite this as 4 times x plus 2. See that? Over 3 times x minus 4. Okay, and I would actually accept either answer here. So if you didn't factor that 4 out, right, because you might not have noticed that these have a common factor of 4 that can be pulled out, that's okay if you didn't notice that. All right, if you left your answer like this is perfectly fine. But the reason that I like to pull that 4 out is because there's a chance that I can get a common factor here that might cancel. All right, so I would accept either of these answers. They're both correct. All right, let's do another one. All right, so when I look at this one, again, I look at the bottoms, and I notice these are not the same. All right, they're not the same denominators. I also noticed they didn't put parentheses on these, which annoys me, so I'm going to put some parentheses on those. And I'm going to use my trick of multiplying by 1 to get these denominators to be the same. So this one has an x minus 1, but it's missing the x plus 5. Right? So I'm going to multiply top and bottom by x plus 5. Right? So I'm just multiplying top and bottom. Now, this one has an x plus 5, but it's missing the x minus 1. So I'm going to multiply top and bottom over here by x minus 1. All right, so you kind of see what my strategy was there. I just multiplied those two bottoms to figure out what my new denominator is going to be. All right, so we'll come down here and let's actually write this out with the multiplication. So in the top, we're going to have 2x times x plus 5. And notice it just looks like I reversed the order, and you can do that with multiplication. This will be over x plus 5 times x minus 1 plus. And then over here, we're going to have 3 times x minus 1 over x plus 5 times x minus 1. There we go. All right, so now that I've done my trick, my multiplying trick by 1, I look at my denominators and I can see now they are the same. All right, so I can actually do the addition part, which is where we add the two fractions together, and when we do that, we keep the bottoms. All right, so my bottoms are x plus 5 and x minus 1. All right, the technical term is denominator, right? My denominators stay the same. So we're going to have x plus 5 and x minus 1. All right, so there we go. And then I'm just going to add the tops together. So we'll get 2x times x plus 5. That was the top of my first fraction, plus the top of my second fraction. And there it is. Okay, so now technically we have added these two things together, but we can do a little bit of simplifying here. So I'm going to work on that using my distributive property. All right, so here we go. So if I do 2x times x, we get 2x squared. 2x times 5 is 10x. 3 times x is 3x. And 3 times negative 1 is negative 3. All over x plus 5 and x minus 1. Okay. And we can yet do more simplifying, right? Because we can combine like terms here. So we'll get 2x squared plus 13x minus 3. All over x plus 5 times x minus 1. Okay. All right, so, and this is where I would leave my answer. In other problems, you might factor the top here or attempt to factor the top. Sometimes it's not factorable, but if you did factor, there's a possibility that you could cancel out another factor in the end, okay? But if you got to this point, I would be perfectly happy with that. The only other thing that I want you to consider and make sure that you do is to talk about your excluded values, all right? So remember, the big no-no when it comes to fractions is dividing by 0. So if you can think about what numbers would create zeros in the bottom of the fraction, then you need to make sure that you exclude those from your domain. In other words, we're telling the person that is using this function they cannot use certain values because it would cause a division by 0. All right, so the way that we find those, we take the factors here in the bottom, so x plus 5 equals 0. I want to know what value of x creates a 0, so I just set it equal to 0 and solve. Right, so we would subtract 5 from both sides, and you find that x equals negative 5. Right, so we're going to say x cannot be negative 5. Right, because if I put a negative 5 in here, you get negative 5 plus 5, which creates a 0, and that would be bad. All right, that would create an asymptote on our graph. It would cause an error in our calculator. Can't do it. All right, so then we come over here. We do the same thing. I'm looking for a number such that if I subtracted 1 from it, I would get 0. If you can't think of it off the top of your head, then just set up the equation. Right, so we can do x minus 1 equals 0, and then solve, and you find that x equals 1. All right, so 1 would be the other value that we need to exclude. All right, let's do one more. Okay, so So we've got x plus 3, x minus 3 in the bottom of this one. And then over here we have an x plus 3. So the denominators are not the same. So I'm going to put this in parentheses because that annoys me. And I look at this one, it's got an x minus 3. This one does not have an x minus 3. So I'm going to come over here and I'm going to multiply top and bottom by x minus 3. And then I'm going to multiply. Right? So we've got 9 minus 3x. And we've got x plus 3. X minus 3 plus 2x times x minus 3 over x plus 3 times x minus 3. Right, so all I did, I just did this multiplication over here. And now when I look at my two fractions, look at the denominators, they're now the same. Right, so I can come over here and I can actually add these two things together. So I'm going to take the top of the first fraction, 9 minus 3x, and I'm going to add to it the top of the second fraction. So we got 2x times x minus 3 all over, and then we've got x plus 3 and x minus 3. Okay. So now we have technically added the fractions together. Now all we have to do is a little bit of simplifying. Okay, so we've got 9 minus 3x plus 2x. We're going to distribute here, right? So it'll be 2x squared minus 6x all over x plus 3 and x minus 3. And we keep going, right? I'm going to combine some like terms here. So I've got negative 3x and 6x, right? Those two are like terms, so I can combine those. So I've got 9 plus 2x squared minus 9x all over x plus 3, x minus 3, right? And that's where I would leave my answer. Like I said, I think if you get to there, I would be happy. Okay, so this is perfectly fine at this stage. And then don't forget your excluded values. So x cannot be negative 3 and x cannot be positive 3, right? Because those would be the two values that make zeros down here. All right, guys, that's it for today. Have a great day. Hope that helped.